All right. Let me just. Whew. All right. Sorry about that. Let's go ahead and get going real quick. We already lost, 10 minutes. So yeah, let's get going. My name is Billy Korando, developer advocate with IBM. If you have questions, you can find me at Billy Korando on Twitter or email me at william.korando@ibm.com. Just a couple of quick things. We have a newsletter. Actually, I wrote our most recent newsletter for the team I'm on at IBM. We just kind of cover what's going on in the world of Java, and you can subscribe to it there. Also, if you need a free and open source and secure version of JDK, check out .openjdk.net. If you leave this presentation with an intense desire to know more, probably going to go through a little bit more quickly than I was anticipating. But where I built this presentation off from is part of a series I'm writing on Living on the Cloud, which is all about presenting, and actually 1 second, let me just make sure I have this Crowdcast window open so I can see any questions that come up. I'm guessing hopefully everybody hears me still and everything. But if you have any questions or if you want to know more, kind of dig deeper in some of the stuff I'm covering, I'll be publishing the 3rd article in the series sometimes later this month. It's a real deep cut into Tekton, which is covering very much all the stuff we're going to be covering in this presentation. So what is Tekton? I'm guessing you're kind of here to learn about it. Can I present as full screen? Actually, I think that would need to be you need to full screen your presentation for it to be full screen.
Okay, let me try. Let me try to put it in a full screen. But you can continue.
Okay, yeah, I'll continue while you work on that. So what is Tekton? So like is often the case now, it is an open source project. But what it is, it's trying to provide a definition framework for building continuous integration, continuous delivery, and continuous deployment pipelines, which we'll kind of get into just a moment here. But it's built off the Kubernetes API. So then as a result, it can run on your Kubernetes cluster. And then of course, obviously, if you're already familiar in building and working on Kubernetes, then it's going to be kind of good to also have the definition framework for your pipeline tools to also then be using Kubernetes. So you kind of have that common same behavior. You're not going to have to relearn a bunch of different things. Though granted, Tekton does have a learning curve attached to it, which I'll get into here also in a little bit. It's currently in beta, but kind of from having talked to some of the developers on the Tekton project, a lot of the API is getting pretty firm. So a lot of what I'll be showing here, and maybe in some of the code examples I'll have linked as well, or be able to get sent out, they should still be working even once Tekton goes GA. So a couple of things about Tekton. A key goal was the extendability of the framework. So you can obviously fill in the gaps you might need that Tekton doesn't provide out of the box, kind of like in the same way Kubernetes doesn't try to solve every problem. It's just trying to be a container orchestrator. Tekton is just trying to be a CI/CD framework. And if you need to fill in additional gaps there, it allows you to be able to do that. Reusability is also another key architectural concept within Tekton, and it kind of comes with its trade-offs and benefits, which we'll touch on here kind of towards the end of this presentation, how it's both good and bad. And then also flexibility, kind of just also like following on how with Kubernetes, where it's just as long as it runs in a container, you're good. That's kind of a little bit here at Tekton. Ultimately, kind of what we're running to be able to perform the task within the CI/CD pipeline is all running in containers. So it really opens you up to be able to do kind of whatever you want. But then that flexibility can also make things a bit abstract, a bit difficult to follow. Certainly, as I was trying to learn about Tekton earlier in this year, it does have a steep learning curve. Hopefully, something we're going to make it a little bit more gradual with this presentation. So just to quickly go over what is continuous integration, continuous delivery, and deployment, I found this, some of my colleagues put together a really good graphic kind of explaining like an overview. And I just kind of recreated it for this presentation because I thought I did a really good job of explaining the difference between them all. So with continuous integration, I mean, really what we're talking about anymore is it's going to be starting with a git push to some sort of shared repo. There's many ways you can start it, but that's really going to be kind of how it's going to be happening anymore in the world. And so in this shared repo, you push to there, a build happens, and then you're going to do some sort of validation. I used a very nebulous term, but that's going to encapsulate everything like automated testing, static code analysis, security scans, and a bunch of other behavior like that to make sure that the code is up to snuff, up to what you expect it to be. And also ideally, when all these steps are happening, it shouldn't be developers directly committing to like your main master trunk or whatever the production branch that you're going to actually eventually be pushing off to production, but some sort of branch that's eventually then going to be merged in. So that way, if some sort of issue comes up during these steps, it's much easier to roll back. I mean, after all, it's not even there. You're just going to, hold off and actually integrating that code until it all actually works with the existing code, and then you continuously integrate it into that production branch. From there, you go to continuous delivery, which is going to be delivering to some sort of near prod environment. It could be stage, it could be dev, it could be kind of wherever. But there could be some sort of like parallel exploratory testing going on, dog fooding within your organization, or some other thing, and also just to maybe confirm that it's actually going to be deployable code. And then finally, after continuous delivery, we have continuous deployment, where we go to the glorious land of production to allow our users to build and interact with our application. So continuous delivery, if you're just doing that, you may have some sort of manual trigger to actually deploy to production, whereas the continuous deployment, there's absolutely no manual intervention between a git push and code actually going to production. It will just automatically go through all these steps and then actually go out to production. So Tekton, kind of like Kubernetes, has many different types of resources to accomplishing these goals. And so let's kind of look over through them. We're not going to cover all the Tekton types, but we're going to cover some of the most important ones, the ones that everyone's almost going to have to use when building out some sort of pipeline. So they are task, pipeline, pipeline run, event listener, trigger binding, and trigger template. Now, these first three Tekton types, these are part of Tekton core, and that's what's currently in beta. These last three, event listener, trigger binding, trigger template, these are all Tekton, part of the Tekton triggers project, which is currently in alpha. This kind of goes back to a little bit of the extendability of Tekton, where it's not, again, trying to solve everything at once. So you can kind of add in other sub-projects as well to maybe fill in different gaps. Again, kind of like how Kubernetes allows you to bring like a service mesh like Istio or a package manager like Helm, because it's not trying to solve all those things. Tekton kind of is following that same modular extendable approach. But let's kind of look at what each of these types do. So task, this is going to be a basic unit of work in Tekton. It's going to be executing a series of steps towards some sort of very highly cohesive goal. So I'm going to be kind of mixing some analogies here, but like a task would be somewhat akin to a class within Java, whereas a pipeline might be more of a package level. You're not going to, even though you could do pretty much everything about a pipeline within a single task, you wouldn't necessarily want to, because then it would be very difficult to reuse. But what does a task look like? Here is an example of one. In this case, building a Java artifact using Maven. So at the very top of it, note for the API version, it's tekton.dev v1 beta 1. From there, there's also the workspaces. And this can be like a directory that's passed in from the pipeline for retrieving and storing work products and whatnot within a task. Now, if you want to reference those workspaces, kind of note the nomenclature in a work directory. It's using workspace source, and that's kind of been referring up to the workspaces I had defined above, workspaces source. So if I had another workspace up there called output or git, it would be workspace output or workspace git to then reference those instead. So that's kind of how that nomenclature works. There's nothing specifically special about source or anything like that. You could use any arbitrary string name. So then there's also parameters, of course, that can be provided in. You can provide a default value, or you can have the pipeline provide values if you want those to be overwritten, or there may not even be a reasonable default as well. There's two types of parameters that Tekton allows for. There's string, which is default, and array. And you can kind of see two examples of that here. So if you don't provide the type, it's just going to be assumed to be string. But if you want to do an array, you have to explicitly define it as an array when you're defining that parameter. In this case, I'm doing like from Maven goals that I want to have happen. And so by default, like I always at least want to have package happen, but maybe you want to pass in something different. Maybe you want to pass in additional parameters like debugging because maybe there's something going wrong. So you can kind of maybe overwrite that if you want to do that in a specific pipeline run. If you want to reference those parameters within the task, it's going to be using the kind of bash kind of nomenclature, the $sign followed by parentheses, and then referencing that parameter. So within a task, you can have an end, however kind of meaning what steps you want to have executed within it. And the steps are executed in the order in which they're defined within the file. So here, I only have a single step, but then if I was to define another step after the Maven step here, then that would be executed after the successful completion of the Maven step. And if the third step was defined farther down, then that's the step that would be executed. So the order, the physical order within the file is the order they're executing this. And you'll see why I'm kind of emphasizing this a little bit later when we talk about pipelines. But lastly, so when Tekton tasks are being run, they're basically pods within Kubernetes. And so they're going to be pulling down an image. In this case, I'm referencing the Google Cloud Cloud Builder Maven image. So that's the image that's going to be pulled down and run. And then the working directory, kind of already covered that before, that's going to be maybe used for doing building of the image. And then these are the commands and arguments that are going to be executed when that pipe or when that container starts up. So next we have pipelines. And so this defines a series of tasks towards a specific build or delivery goal. So when I talked a little bit earlier about the data CI/CD overview, for really each of the different stages in it, continuous integration, continuous delivery, continuous deployment, you would actually probably have this defined under a different pipeline. You wouldn't have one single master pipeline that's running all these steps itself. That way you can kind of divide those behaviors up as needed. But let's just kind of look at what a pipeline looks like. I somewhat concatenated this file down just so you can kind of see the different elements of it. But you see, again, we have parameters that can be defined and passed in for the task within this project. And again, the parameters either string by default or array. And then we have the workspaces that are going to be, this can be used across tasks within a project. You can have outputs within tasks and even within pipelines, but typically workspaces will be an easier way of passing information between tasks within a pipeline. It's a lot more robust way of passing information around. So task, you can define, again, an n number of tasks within a pipeline. And here we're giving the unique name of the task and then referencing a task file within our definitions for what's going to be run. So like just a few steps before, like I was referencing like a Maven build, our Maven artifact. Let's see, I can't quite remember. So like the Maven build artifact from source, like if I was going to reference that, that's what I would put here for the name for instead of git clone repo. So here's one task, and here's like another task within this same pipeline. Now, unlike steps in task, the by default, tasks will be executed in parallel within a pipeline. So if you need a specific order for tasks to be run in, then you need to use this run after definition. So here for like the Maven build Java artifact from source that I was just showing a little bit earlier when I was demonstrating task, I want that to, of course, be run after I actually clone in my code repository for the Java artifact I'm going to be build, or for the Java project I'm going to be building. So just you need to use the run after if you have a specific order you want them to execute in. There's also multiple tasks you can define here. So if you want to have a task run after multiple tasks as well, you can do that. But yeah, that's just one thing to keep in mind is the task, they don't have the order they're defined in within your pipeline file has no bearing on the order that they'll be executed in. A few, just kind of summarize a little bit common things also about tasks and pipelines. As I mentioned, they can have outputs. So that's kind of how you could have multiple pipelines for each different stage within like a CI/CD process. After the continuous integration phase is completed, it could have some sort of output, like maybe a reference to the image name location within your container repository to then have that be deployed out to your staging environment. There's also a belief within either tasks or pipelines, there's like a resources concept. You may have also seen it in some of like demo examples. I kind of saw a lot of those in some of the examples when I was researching Tekton, and you should avoid those. That's actually gonna be deprecated and probably removed when Tekton goes to general availability. So if you see those references and demos and examples, avoid those. You don't want to use them. Finally, you also, if you look at documentation, you will probably see task run referenced a bunch of times. And that's something that's going to be automatically created at pipeline execution. You're never going to be defining a task run yourself. That's different from here. In this case, the other type I want to talk about, pipeline run. And this defines a specific instance of a pipeline execution. I kind of realized I referenced pipelines as being package level, but in this example, we're just going to use it as an example of a class, and then to that, a pipeline run would be a class instance or an object of that class. So here's a pipeline run example. This is generating a unique name. So in this case, I'm putting like the deployment image name that I'm building, because that's going to be pretty much like the project name. And then also like a hex value is generated at the end of it just to always make sure it has a unique value. So this is also defining a service or referencing the service account that this pipeline will be using for setting up and creating resources. So like when those tasks are run, that's going to be actually setting up a pod on your Kubernetes. So it needs to have some sort of account to execute those under. And then this is referencing the pipeline to be executed. So a few slides ago when I was showing the pipeline, the name of that pipeline was project pipeline. So that's referencing it. That's how that link is made. And again, the parameters are passed into that pipeline that would then override any sort of default you might have to it. And then also for workspaces, like this is kind of like providing the underlying backing for that workspace or that work directory. And, they just could also be good for maybe, like this Git repo that can be pretty ephemeral. Like you only want it to exist for that project pipeline run, but you may have like a Maven cache you want to have persist across pipeline runs. So you can kind of change up how you want that defined for the different kind of workspaces if you kind of went down that path. So next we have EventListener, and this is going to provide an addressable sink for events. And this is an example of one. Note at the top how this is using Triggers Tekton Dev, and the Triggers project is currently in the alpha phase. So there's more of a chance, and I realized alpha is misspelled up there. Ignore that. It's supposed to be alpha like how I have under the note there. But it's still like some of this API might change by the time it actually goes GA. It is, after all, an alpha. Again, for the event phase of it, you would need a reference to surface account for creating some resources. This is the like you can provide multiple triggers that should be executed whenever an event hits this sink. And then you can reference the trigger bindings and templates, which we're going to touch here in just a moment. So a trigger binding can then extract fields from the event to pass on to the trigger template. So if I was to pass in like a JSON message that was an event, and I needed to get, in this case, like the Git repo URL and the commit ID that I'm going to then be cloning my project from, like I would reference those fields within like that JSON message or XML message to extract it out of there. Trigger template, this can be used to create resources will still be used during the pipeline execution. So like that workspace directory here, like so you have a bunch of resource templates, or if I'm creating like some secrets that I'm going to be using for like configuring my environment, you can also see how I'm creating those secrets there. And as I was mentioning, the persistent volume claim for like the backing of that workspace, like that's where I'm also creating that here in this Trigger template, and that's typically where you would put those. So what does this look like overall? Well, kind of like all these tasks I was showing you, and then there's some other, or these types and resources I was showing you, and a few others I didn't have time to get to. This is what the overall would look like. Here to the far left of the screen would be the GitLab push event listener. So it's going to be sitting here listening for some sort of event, like a commit coming from like a GitLab repository, and it's going to send a message, and it's then going to trigger off the build for the rest of the project. In this case, it's a very simple proof of concept pipeline. So it's actually deploying out to a Kubernetes instance on the cloud. But like I said, you probably would actually have that separated out into a different pipeline. To kind of focus in on the event sync flow, like from whatever event you're going to be having listening to, like, it's a GitHub. I mean, again, it's probably generally going to be Git repositories, though it could be also having like where a pipeline completes, and it's going to then send a message to some sort of event. But it's going to send like a post to some sort of URL, and then that trigger binding is going to then read those fields from the post and then pass that along to the trigger template, which then kicks off the pipeline build. So I talked a little bit earlier about one of the kind of weaknesses, or one of the strengths and weaknesses of Tekton is its extreme reusability. So I know this is really, really small text. I'm not trying, I don't look at too much. But so here in all the red circled boxes, it's basically the same parameter value. I'm kind of passing through all of this pipeline. And this is a very simplified version of the pipeline I was showing earlier. But here, like this path to the deployment file that I'm going to be eventually using to deploy the application out into like the cloud instance, I kind of have it all the way defined up here in the trigger template. And then within the pipeline run, I'm passing it from the trigger template to the pipeline run. And then from the pipeline run into the pipeline, I'm again passing that parameter from the pipeline into the task. Within the task itself, it's also defined. And then finally, within the step of the task is where I'm actually using that value. When I was first getting familiar with Tekton, like this was very kind of confusing and frustrating, I guess. Just this long line of tracking down from like where a parameter is first defined to where it's actually used. It's just something I kind of wanted to point out that I did, at least personally, find it a little bit confusing, a little bit difficult to initially understand when I was first starting working with Tekton. So I just kind of wanted to point that out so you can kind of understand. You would probably define it and referencing parameters in a lot of different locations as you're actually using Tekton. So while this can be a bit frustrating, the benefit of this is you get a lot of reusability out this. And so how I want to actually didn't want to do that. Let's keep that in presentation mode. So one of the benefits of this is, and again, I kind of apologize. I had to get my browsers all set back up again. But to continue on, is you have these Tekton pipelines. So you can have both these Tekton catalogs, which can provide predefined resources. Typically, it's going to be tasks, but it could be anything like maybe even event listeners and trigger bindings for maybe common things like reading in like a message from GitHub on how you can have this stuff predefined. So that can actually save a lot of time. You can have it both in this cases. These are like kind of like open source. This is like the Tekton CD catalog. So this is kind of for everyone who's using Tekton. But they have a bunch of predefined tasks. In this case, like I have, let's see here. Oh wait, yes. So like instead of creating my own task by hand for cloning from a Git repository, here this is already predefined task, which is quite complex. It's almost 400 lines, but it has like error checking, logging, and it's much more robust than what I could write myself. And that way, a lot of the common issues you may run into before, it's already been kind of found out. Large open source, any sort of issues and kinks have kind of already been worked out a whole bunch. So you can have that, of course, cross-organizational, fully open source, or even within your organization, you can create like some sort of Tekton catalog. One moment as this quickly loads. Yeah, I'm soon running out of time. Unfortunately, we lost a few minutes here at the very start of it, so sorry about that. So here in this proof of concept I talked about at the start of the presentation when I mentioned the Living on the Cloud series, I kind of go into much more depth in this area, kind of explaining some of the stuff here. But like I created some common tasks that like maybe hypothetically I would use within my organization, such as maybe for how to like to bind a service, like because I'm on IBM Cloud, in my example, like how to bind a service to my cluster so then I could connect to like a database or something. So like I could create a task, and then anyone else in my organization who needed to bind to like a service could then just reuse this task instead of having to redefine it themselves. So whereas, maybe that if they kind of scale back into reusability, it'll be a little bit easier to kind of reuse or to like maybe understand something by kind of abstracting everything out, by adding all those abstraction layers. You can kind of get some of this reusability, which could become kind of beneficial in these areas, particularly if it's a more complex task than kind of some of this, very simple POC examples I have here. Like I said, this get clone task, it's like 400 lines. And so not having everyone have to rewrite those 400 lines every time and copy and paste, actually referencing like a same shared common task can be pretty beneficial. Just to quickly look at what it looks like when one of these tasks run. So this is running on IBM Cloud. You don't need to use that, but I figure if you're going to be probably using, if you're on the cloud platform, you're going to be kind of making use of the integrations for this stuff instead of having to write this out all by hand. But you can just install it on Tekton or install it on the IBM cluster and install the Tekton, the TKN client interface or the command line interface and just run it all from there. You don't actually have to use all of this. You don't have to integrate with your cloud if you don't want to. I'm just using this as an example. But you can see how we have all these tasks run, the login from those tasks, the context of what's being passed in, like the event payload, and along that sort. One other thing I also want to show real quick to kind of show how this all ties together. Oops. In the cloud. So like how this event, how like it knows when I committed something to my Git repository is on your cloud provider, or when you're setting up a trigger or an event listener, it will set up like an addressable endpoint. In this case here, this like addressable endpoint where your GitHub, or in this case GitLab project, it will send a JSON message to it whenever, like whatever event you're looking for. So like in this case, a push event. So whenever I'm pushing or making changes to it, or maybe whenever I'm merging stuff, I want that to send off a trigger or send off a message to this endpoint, again, which is where my event listener is listening for any sort of messages coming in. And so GitHub kind of will also send off a request body that's just similar to this. You can check GitHub's documentation for the exact what this message will look like. But from here, I can get like the Git URL and the Git commit ID, then to actually be able to run that clone. So I think I'm at time. I believe I had from 12:10 to 12:50. So, and this kind of is at the end point of the overall presentation. So if you have any questions, please kind of post them in here. I'll be happy to answer them. So, okay, for YAML validation, so there may be some other external tool out there. And this will probably also be the case for also really any cloud platform to provide it, but at least on IBM Cloud, this is still a little bit in beta, so I'm kind of showing off something that's not fully released yet, but they have a way they provide this linter to where it shows like all the Tekton definitions that you're pulling in, and then you can validate it to make sure, it looks like there's something wrong with the validator right now, to see if there's any sort of issues with the YAML or something like that, like you're referencing a resource that doesn't exist. And I imagine most cloud platforms will probably also provide something like this if they're providing good Tekton support. There could be also some tools out there as well that can integrate with like your IDE to make sure that it's also being correct. Actually, I do want to touch on, that does remind me before I forget, is also typically you probably would provide within the project that you're building a pipeline and information on how to be built. So like here, I have the pipeline on like all the tasks to be executed when I'm building this project, at least building the artifact. And again, in this case, I'm also defining that's going to be deployed out to the cloud, but you probably would only do the CI portion of this in a more real world scenario, but you would probably want to put that into the actual project itself, just so that kind of says like, oh, this is how we're supposed to build this project. It's kind of good to have like a single source of location for running these projects. Is there a way to test pipelines locally? If you have a local Kubernetes instance running, you can install Tekton onto your local laptop or maybe dev region, and then you can download the command line interface tool, TKN, to maybe kick off these things locally. Also, up here above this, and this is also a little bit where like some of the reusability can kind of get a little bit frustrating. So because the trigger template is going to be kind of defining the values to pass into the pipeline, I had to kind of include both the trigger template and the pipeline if I want to be able to properly pass in like some different values to go in to the pipeline, and to override the defaults. Like a really good example of that is if I like typically maybe just want to always do like a Maven package, but maybe I want to run some other goal, or maybe I want to pass in like a debug parameter. I found this a bit weird and frustrating how that will work with Tekton right now, and I wish it could work a little bit better to where it can be a little bit easier to kind of override values, and it could be a little bit with also IBM Cloud's Tekton integration, where it's not easy to provide overriding values for this. So like if I wanted to provide like a different Maven goals here, that integration isn't working that well yet. So I think the next presentation here is in 5 minutes. So real quick, let me go back here. If you have any more questions, again, DM me at Billy Korando or email me at william.korando@ibm, and I'll be more than happy to try to answer any questions you have. Again, I apologize for the initial 10-minute delay. I don't know, technology, it can be weird at times. So, but yeah, thank you again for attending my presentation. Thank you again for JConf Mexico for inviting me. I really wish I was down in Guadalajara right now, but hopefully I'll be able to come down next year.
Hopefully. We have a couple questions, Billy. One of them is, do you use any tool to assist with the YAML validation?
Yeah, so I did kind of answer that a little bit earlier, that at least within the cloud platform integration, there is this tool here for validating YAML, And then to his other question about running pipelines locally, you would have to have a Kubernetes cluster running locally and then install Tekton on it to be able to run a pipeline locally.
Great. Well, if anybody else has more questions, they can contact you to Twitter. You are more active in Twitter. I haven't seen that.
Too active, really. Too active. But yes, yeah, I'll be there. Definitely reach out. And I'll be more than happy to answer questions. And no questions too silly to ask. So, yep.
Great.
All right.
Well, Billy, thank you so much for being here again. This is your second time here with us, right?
It is, yes. Yeah, I had a great time last year. So.
Yeah. You were no victim of the tacos, oh yes.
Yes. Oh, yes. I mean, I know it's not Guadalajara's specialty, but I do love Al Pastor tacos. It's one of the reasons I eventually want to go to Mexico City, particularly, just because I know that's their specialty there. So I'll be pie in heaven.
Well, maybe the next year, we can have the opportunity to have you here in Guadalajara, or maybe somebody else in the panels of the speakers was considering to go to Cancun. Cancun is a good option, also.
I'll do that as well.
Okay. Thank you, Billy. Nice to meet you.
Thank you. Thanks
see you again. Bye.
Good to see you again. All right. Bye.